everyone. Today, I am going to talk about visualization of data, low-code tools for creation of management dashboards, benefits of visual analytics tools for business users, and how these tools are represented in Diasoft's digital Q.Sensor platform. Let me start with the question: why is data visualization so important? Why has Diasoft placed a special focus on it? It is widely known that due to the visual superiority effect, people perceive graphic information better than a plain text, or even video content. To ignore this feature means to ignore human nature. We also place a special emphasis on the interactivity. Static graphs or images cannot impress anyone nowadays. That is why, when we designed the platform Digital Q.Sensor, one of the top priorities was given to the interactivity. That is to the ability of the user to interact with dashboards and visual representations of information in different ways. Another know-how used in our company is to package the best practices and the best examples of dashboards into a methodology. It is important, because if a company simultaneously creates many dashboards, separate users and teams can introduce their own designs and approaches, which leads to inconsistency and even creates visual dissonance. That is why it is essential to continuously accumulate the best results in a methodology and reuse them to ensure consistency. It is not enough to simply extract, export, generate and deliver the information to the user. We need to visualize it. In this slide, I'd like to elaborate a bit on the place of data visualization in the overall data processing process, that is from the moment when the information appears in systems that support business processes, up to its delivery to the business user. Delivery in the broad sense. What I am talking about is the final stage of this process. Digital Q.Sensor is located in the right part of the scheme. It interacts with a data mart or a data warehouse at the database level, ensures transformation of data into graphs, visualizes information, and delivers it to the user. Let us discuss how a company can start data visualization, if it has no established practices or approaches yet. Usually, a company has some approved KPIs. They can be described in some documents, managed with the help of Excel files, or otherwise tracked by the company. The business can achieve the first valuable results simply by copying databases where these metrics appear, that is by using database replications. You do not need any expert teams or coding here. These are all standard database capabilities, and the company can start creating first visualizations on top of these replications. You can combine several approaches. For example, you can collect actual data, or facts, from a database replication. Surely, we cannot work with online data here, and there will be a little lag in data, but still, it brings value for the business. As for the planned figures, if the company uses Excel to record and manage its business plans, these figures can be downloaded directly from the respective Excel file. With Digital Q.Sensor, we can combine data from different sources, even within the same diagram. Let me switch to the design and UX of the target solution now. Judging from our experience, customers rarely fully envision the final outcome that they want to get at the end. They always change their mind during the implementation. The customer can start by simply drawing on the paper what he would like to get, and the person responsible for setup of the solution will implement these ideas in the system. This process is iterative. The customer adds or deletes something from the design, simply erasing these parts from the scheme, and we repeat these changes in the system. The platform allows doing it quickly and easily. Through these iterations, we come to the ideal solution. Ideal both from the customer's point of view and, of course, from the perspective of the accumulated experience, methodologies and design consistency, which guarantees that we do not create unmatching designs. Significantly, we can quickly integrate charts and separate graphs into end-user systems. Normally, these are simple and clear KPIs, such as plan-to-actual ratio, the number of registered applications, etc. Such KPIs are easy to calculate, and they are normally based on simple requests. Using standard platform capabilities, we can quickly set up a required chart, add a meter for users and build it into the user interface of any system, even a third party's. Speaking of banking, we can integrate such a chart into the single-screen customer service interface, so that a teller or a customer service manager could, at any moment, check how they perform. Track whether they meet KPIs and how they progress, in comparison to other colleagues. Let me demonstrate some of visualizations which we use in our company. The first example demonstrates how an element, selected in one chart, is used as a filter for all other charts in the same dashboard. Here, we select one of the data bars in the upper part of the dashboard, and see how it affects all other charts. Here's an example of zooming. We move the red control element, and it changes all its environment. You can see that all charts at the bottom of the dashboard are regenerated, depending on the position of the round red button. Since we made a special focus on the interactivity and dynamics of dashboards, all chart types in this component can also change. Here's another example of an interactive dashboard. It has several filters at the top. You can see that when we select specific values in these filters, all charts at the bottom change accordingly. The graph in this example allows filtering data and changing the type of graphs located under it. In addition, we can modify the type of visualization at any time, for example, change any graph into the table or another visual type. Here are some examples of HR dashboards. In this example, we can zoom data by date. We can switch between different types of graphs from left to right, or go back to the home page. This chart also represents a convenient tool for visual analysis. Now let us speak about the uses of visualizations. Traditionally, they are divided into three categories: read-only, self-service and IT users. The read-only category includes users who can view graphs, use their interactive capabilities, leverage dashboard features, export data into Excel files or documents, and export images as PDF files. The self-service users are business users who can create their own graphs, charts, and dashboards. These users do not have special IT skills. They cannot code, but they can use the self-service functions for visualization and analysis of data. And they can solve these tasks using only no-code tools, supported in our platform. The third category of users is IT specialists. These are the most advanced users, who can create elaborate interactive dashboard. Here, it is important to highlight that even creating a complex control center, we will need to involve only junior to middle-level JS and SQL developers. In conclusion, I would like to emphasize that we can and should visualize data from information systems. To achieve this, we do not need to embark on complex large-scale projects. Visualizations can be implemented within a week, without any super teams. All we need is some committed business customers and several IT specialists who understand SQL and maybe JavaScript. We can move iteratively, that it get the first valuable business results in several days or weeks, and come to complex visualizations and methodologies later on, without any losses or decrease in performance. Speaking of the business value, I would like to highlight that, judging from our experience, the solution influences the users responsible for execution of tasks, makes the assessment of their work inevitable, and this changes the mindset of both the responsible employees and the managers. This approach makes it easier to monitor the quality of work. One more feature of the solution is that all visualizations, built on digital Q.Sensor, can be integrated into external systems, including systems that generate data, and be used as command elements there. For example, a chart created in digital Q.Sensor can be integrated into a CRM system. After this, the user can click on the chart, and manage some processes in the CRM system. To recap, I'd like to underline that digital Q.Sensor covers the broadest range of various use cases and tasks, regardless of the company industry or business features. It is a cross-industry product, based on the most advanced data visualization technologies, which solves multiple managerial and user tasks, related to visual analysis of business data. To learn more about digital Q.Sensor, please visit the product website at www.diasoft.com/sensor.